Okay, we are graphing just like we did yesterday. Yesterday we built a table and plotted points and made lines from there. Today we're going to graph, but we're going to use intercepts, okay? An x and a y intercept. So these are all given to you in the same way. See, the x and the y are in the same place, okay? On the same side of an equation. That's called standard form, okay? So standard form is ax plus by equals c, okay? To get intercepts, if I want a y-intercept, my x has to be 0, right? If I multiply a times 0, what happens to that piece? It just goes away, right? So I could just take by, make that equal to c, solve for y, there's your y-intercept, right? So I would get 0, whatever your y is, right, for your y-intercept. And I can do the same thing for x-intercepts. If I want an x, my y has to be 0. So if I change that y to a 0, what's b times 0? 0. So it's not there anymore, right? So I can take my ax term, make that equal to c, divide both sides by the a value, and you get your x-intercept. So you would get x, whatever that number is, and then 0, okay? So I feel like you're going to like this a whole lot more than you liked yesterday, okay? Well, good. Good. All right, so we're going to get an x-intercept, we're going to get a y-intercept, and it only takes 2 points to make a line. So once I have those 2 points, we're going to connect them and call it a day. Ready to do it? All right, let's do it. My first one, 2x minus 4y equals 12. Okay, you want to do your x-intercept or your y-intercept first? Your x? Okay, so again, to find an x-intercept, oh, come on. There we go. You're plugging in 0 for your y, which is why that piece cancels. Okay, because 4 times 0 is 0, and I'm not going to say plus 0. So we have 2x equals 12 left over. So x equals 6. So your intercept is 6, 0. So remember, there's my x's. Find where x is a 6 and put a point. Okay. We're going to do it again, but with my y's. Okay. So for a y-intercept, we make our x 0. So 2 times 0 minus 4y equals 12. 2 times 0 is 0. Don't need that. Now we're left with just negative 4y equals 12. What is y? Don't say 3. Negative 3. There you go. We divide both sides by negative 4, and we get negative 3. So my y-intercept is 0, negative 3. Go to my y's. Negative 3 means go down. So go down 3, which is about right here. And now we connect them. Like that. So we're plotting 2 points and we're connecting them. That is it. Okay. All right. We okay? Sure. All right, let's do our next one. I have x minus 2y equals negative 8. X-intercept first, so what's going to be 0? If I want x, then I need to make y equal to 0, because you want x equals a number, right? What number goes for x? So you don't want y, okay? So if I make y equal to 0, 2 times 0 equals negative 8. What's negative 2 times 0? 0. So what are you left with? X equals negative 8. So that point is at negative 8, 0. That means I went to the left and I didn't go up or down. So we're still on the x-axis. Down here where x is negative 8. Feel good about it? Good. So now for my y-intercept, if I want to know what y is equal to, I need to get rid of my x. I get rid of x by making it equal to 0. So 0 minus 2y equals negative 8. So that's gone. Yep. So negative 2y equals negative 8. We divide both pieces by negative 2. Right? No, you're right. Positive 4. So your y-intercept, when my x is 0, my y is 4. Does that make sense how we write the point? When our x is 0, my y is 4. So I didn't move left or right, but I did move up here to 4. And then we connect. Okay. Give you a couple more seconds before we move on to the next one. While we're waiting, if you want to go ahead and try to start the next one, you can. See how my next one, we have 4y equals negative 12x plus 36? Is that in standard form? No. It doesn't have to be, but if you want to put it in standard form, you can. All right? How would I put it in standard form? We're going to add 12x to be with my 4y. So standard form, your x and y are on the same side. So I'm going to add 12x over here. So now we have 12x. Whoop, there we go. 12x. We have a positive 4y, and we are equal to 36. So standard form, you get x and y on the same side. All right, if we want an x-intercept, what do I make 0? The y. Good. What's up? No, because you added it over to the other side. We moved it over so x and y were on the same side to make it standard form. All right, if we want my x, we have to make my y 0. Because that shows we're not going up and down. We're only moving left and right. All right, so this becomes 12x equals 36. I heard someone say it over here. This gives me x equals 3. So the point, my x is 3 when my y is 0. So I didn't move up or down. How did I move? Which way? Just to the right. Yep, we went to the right 3 units. About right there. I'm going to do green. Switch it up. Okay, now I want my y-intercept. To get my y, what do I make 0? The x. So 12 times 0 plus 4y. Some of you are catching on to some shortcuts. So that cancels. We have 4y equals 36. Divide both sides by 4. And we get y equals 9. How do I write that point? Is it going to be 9, 0 or 0, 9? 0, 9. Remember, it goes x and then y. I made my x 0, and I got a y of 9. So did we move up and down? Or which one did we move? Up or down? We went up. Did I go left or right? We didn't go left or right at all, okay? Just moving up and down shows it's a y-intercept. So up 9 puts me about right here. And then we connect them. Like that. Do you think you can try one? And then we check each other? I want you to try. I want you to try. I'm going to pause. I want you to try, okay? And guess what? If you mess up, we're going to fix it, right? I just want you to try, okay? When you make it equal to 0, then that term is no longer there because we're not going to say plus 0, right? So when I have 2x equals 10, I divide both sides by what? We divide by what? What do we divide by? We divide by 2, so I get x equals 5. Where is x5? It's right here. Okay? How do I get my y-intercept? I say 5y equals 10. Divide both sides by 5. We get y equals 2. Here's my y's. There is y equals 2. And then we draw our line. That is not a good line. You did? Yep. Don't second guess yourself. The coordinate point for this one would be 5, 0. The coordinate point for my y is going to be 0, 2. Yeah, you didn't finish it. You had half of it. You had half of it. All right, let's work our way to the back, please. All right, Angelina works as a nurse in an emergency department. Some patients who are dehydrated require rapid rehydration with IV saline. I can never say that word. Intravenous. It's an IV. Suppose the function 30x plus 3y equals 1,500 represents the amount of saline in milliliters left in the bag y after x minutes. Graph the amount of saline left in the bag as the function of time. All right, so first off, let's graph. It's a real-world problem, so we're only going to need the first quadrant. We're only using positive numbers, right? We're not going to go negative in time, and once the saline is gone, we can't go negative, right? So we're going to stay in the first quadrant. We're only doing positive numbers. All right? Find the x and y intercepts and interpret their meaning in the context of the situation. So we're going to do that first before I graph anything. I need to know what numbers to use, right? To get my x-intercept. Okay, so we're looking right here. 50x plus 3y equals 1,500. Which one of those has the x?
50.
The 50. So we're going to say 50x equals 1,500.
It's 30.
Divide both sides by 50. And we get x equals 30. So like the zeros cancel, right? 15 divided by 5 is 3, and then you put a 0 on the end. Oh, it's okay. It's because of the extra 0. All right, let's do the y's. What has a y with it?
3.
The 3. So we're going to say 3y. I'm writing way too big. 3y equals 1,500. Divide both pieces by 3. We have a y-intercept of 500. Okay. So now I kind of can gauge where I can, how I can count. So my x's, you want to count by 10s? 10, 20, 30, 40, 50. What do our x's represent, by the way? What did it say? Oh, right here. X minutes, right? So this is minutes down here. And I'm going to go ahead and put me a dot where it was 30. How do you want to count my y's?
10.
We got to get to 500. Let's count by hundreds. Yeah. 1, 2, 3, 4, 500. What does this represent?
Y after X minutes.
How are these being measured? Miles, ounces, oranges. What does it say? Milliliters. So I'm gonna do an ml right here. This is for milliliters. Okay, where are we gonna put our point? At 500. Good. Thank you. And I'm gonna draw my line. Okay. Think about it. Does this make sense? If you haven't had to have an IV, maybe you've seen it on a TV show or something, okay? It's when they drip medicine into you, right? Does it make sense that that bag of medicine gets smaller?
Yeah.
So does it make sense that my line is going down? It's showing that less and less medicine is in the bag. Does that make sense? The 30 is 30 minutes. 30 minutes for what? What is that? 30 minutes for the bag to empty. Perfect. 30 minutes for the bag to empty. Good. Very good. What does 500 show me? So it's 500. I know it's a Y. So if I have 500 milliliters, what does that mean? How much was in it at the start? Good. So we started, put it over here, started with 500 milliliters. Good. I'm going to put of saline. Good. So your y-intercept is what you started with. And then showing that it 30 minutes we hit 0, it took 30 minutes for the bag to empty. Very good. Find the domain and range and interpret their meaning in the context of the situation. All right, so we're going back. What is domain? Is that my X's or my Y's? My X's. So my X's go from what number to what number? Yes, 0 to 30, yeah. My X's went from 0 to 30. Because what happened? That was the time to empty the bag. Yeah, D for domain. I'll zoom in. Our domain was 0 to 30. It took 0 to 30 minutes. That was the time period of the bag. All right, and then my range is my Y values, right? These were my X's. My range is my Y's. So what's the lowest Y value we have? How low does my Y's go? What was it? 0. We go as low as 0, but we go as high as what? 500. So what does that show? Total milliliters in the bag. Yeah, good. So between 0 and 30 minutes, we had between 0 and 500 milliliters of saline. Good. Y'all did very good on that one. Last one. Yep, we got this. That's multiple choice, right? I think. Yep. All right. Let's do it. You ready? Still writing? Give you a second. The back. Let's see. What is it? Oh, so we have to find them, and then we pick the graph that matches it. So it's like half and half. We good? Time for peanuts. That's the next problem. All right, here we go. A farm produces about 4,362 pounds of peanuts per acre. 1 cup of peanut butter requires about 2/3 pound of peanuts. If 1 acre of peanuts is harvested to make peanut butter, the function y equals negative 2/3 x plus 4,362 represents the pounds of peanuts remaining y after x cups of peanut butters are made. Find the x and y intercepts. All right, so we had an equation like this in the front where my x and y weren't on the same side. So what are we going to do first for this one? Yeah, let's move my x to be with my y. Okay, and we're going to do that by adding the x. So we're going to say positive 2/3 x positive y equals 4,362. So my 2/3 was negative. To move it over, we get to make it positive. Now we're going to find our x and our y intercept. What equation am I going to use to find the x intercept?
2 over 3x equals 4,362.
Yep. All right. What are fractions? 2 over 3 is 2. I heard it. 2 divided by 3, right? So to undo that dividing by 3, what do we have to do? Multiply by 3. So let's multiply by 3. Someone help me with the calculator. What is 4,362 times 3? Yep. 86? Like that? Okay. Now what am I going to do? Divide by 2. Good. So now, Isaiah, what's that divided by 2? Thank you. Yep. All right. Now, how about my y-intercept? What's the equation for my y-intercept? That's nice. The end. Right? Didn't have to do anything else. There was nothing else with it. Okay? So yeah, so now we need to pick a graph that shows those intercepts. Okay? Part A. Does it have a y of 4,000 and an x is about 6,000? Remember, these are x's and these are y's. So it looks like it has them switched. Right? So A is out. Hold on. Does B have a point of an x about 6,000 and a y about 4,000? Yes. There is a point a little bit over 6,000 for my x and a point a little bit over 4,000 for my y. So far that one's okay. C, a little bit over 6,000 for my x. Yes. A little over 4,000 for my y. Yes, that one's fine. D, is that a little bit over 6,000 for my x? No. D is out. Okay. What is the difference between B and C? Is it connected or is it not connected? B is not connected. C is. What should it be for this problem? It should be connected. Good. This is a stamp. Yeah. It should be connected. Yep. Stamp paper out. Good.